Right, here we go. So for our next wee bit about suvat and equations of motion, we need to do a wee bit of work on vertical motion, so objects being thrown up in the air and being allowed to fall back down, or just being dropped and falling to the ground. So obviously, for vertical motion, it's gravity that's doing the acceleration. We have studied gravity at National 5. Acceleration due to gravity is 9.8 metres per second per second. Important thing is that it acts down the way towards the centre of the planet, towards the ground, and when we've been using our equations of motion, we've been saying that the direction is important. In the equations of motion, displacement s, initial velocity v, initial velocity u, final velocity v, and acceleration a are all vector quantities, so the direction is important, and something moving in the positive direction is going the opposite way from something moving in the negative direction. So we normally take up the way as positive, down the way as negative. That's the standard way of doing it. It's not always the case, but in the majority of cases, that's what we do. Anything moving up the way gets a positive value, anything moving down the way gets a negative value. So we would usually take the acceleration as minus 9.8 metres per second acceleration due to gravity. So an object thrown up in the air, what will happen is you throw it up in the air, it will slow down, slow down, slow down, and stop at its maximum height, and then it will start to accelerate back down the way. So if it's stopped at its maximum height, then that's something that we can make use of a lot, because we can set the velocity v equal to 0 at that maximum height, and that allows us to analyse motion. So equations of motion, remember that's them there, and an absolutely amazing set of equations that allow us to analyse motion, including motion like this object's being thrown up into the air and being allowed to fall back downwards. So a good way to illustrate that is to do a wee solution to tutorial question 10. So tutorial question 10 is where the ball's thrown vertically upwards from the edge of a cliff, as shown in the diagram, and it's thrown upwards at 4 metres per second. So have a wee look at question 10 in your tutorials, and that's the solution. This is the solution here. So the ball's thrown upwards at 4 metres per second, and question A part 1 asks us to find the height of the ball above sea level at 2 seconds after being thrown. So if we go through our problem solving again, and we do the suvat that we've been practicing, so going through all 5 quantities, finding out what we're looking for, and looking for the information that we're given. So it says height, so we're looking for displacement s. The initial velocity u is given in the question, it's 4 metres per second. The acceleration is the acceleration due to gravity. If we take u as upwards at 4 metres per second, that's a positive value, so acceleration is in the opposite direction, downwards, so it absolutely must be minus 9.8. The question says, where is it after 2 seconds? So that's where the 2 is coming in for time there. Looking at the equations that we've got available to us, then the one that will allow us to solve for s is s equals ut plus a half at squared. So that's the formula. Subbing the values in, u's going in as 4, t's going in as 2, plus a half times minus 9.8, because the acceleration is acting down the way, times the square of 2. The time must get squared, 2 squared. So tidying that up, 4 times 2 is 8. All of that is minus 19.6. So 8 minus 19.6 gives us a displacement of minus 11.6. Now what does that actually mean? That means that the ball is thrown upwards, it comes back down to where it started, and then it falls a further 11.6 metres from the height of the cliff. So it's fallen down 11.6 metres. So it's 11.6 metres below where it started. So the cliff height itself was 33 metres. It's now 11.6 metres below the cliff. So that means it's a height at sea level of 21.4 metres, because the height of the whole thing is 33 metres. It's fallen to 11.6 metres below where it is. So from sea level, that must be 21.4 metres. So that's the answer there. Excuse me. A part 2, it says, what is the velocity of the ball 2 seconds after being thrown? So it's again 2 seconds, but we can do suvat again. We could put we know where it is, it's at minus 11.6 metres. We could put that in since we worked it out, but we don't need to because we have enough information there to just use another equation of motion. So U again is 4, V is what we're looking for, A is again minus 9.8 and T is 2 seconds. So using V equals U plus AT, sub the values in, 4 goes in for U, plus minus 9.8 times the 2 seconds, and for A times T, so that's 4 minus 19.6, which gives us minus 15.6 metres per second, which means 15.6 metres per second downwards. The minus sign is telling us that it's moving downwards because that's what we've used. Acceleration's downwards, and at that stage in the journey, after 2 seconds, the ball is moving downwards. We worked that out. It was 11.6 metres below where it started. It must be moving downwards, which is why the velocity is a negative value. Question B, a wee bit to this. It says, what is the velocity of the ball 2 seconds after being thrown? That was part 2. Part B says, what is the total distance travelled by the ball from launch to landing in the sea? So from launch to landing in the sea, it will go up, stop, where V is equal to 0, come back down to where it started, and then fall the full 33 metres down to the sea. So that D1 there is the distance from where it's thrown to the top, where the velocity is 0. D2 would be the same distance because it would go back down to where it started, and then it would fall a further 33 metres. So if we can work out the maximum height it reaches, then we'll be able to work out D1 plus D2 plus the 33 metres. Right, so let's give it a go. So doing suvat again. U is 4, A is minus 9.8, and let's work out the maximum height there by setting V equal to 0, because V will be equal to 0 at the maximum height. So using V squared equals U squared plus 2AS, 0 equals 4 times 2 times minus 9.8 times S, and then we're solving for S. So 0 equals 16 minus 19.6S, change sign, take minus 19.6 over to the other side. 19.6S equals 16, given S equal to 16 over 9.6. So that's a bit less than a metre. It's about 0.816 metres. So if we take that as D1, add on D2, which is the same, and then add on the 33 metres, that will be the total distance. So I've put that in brackets there because we're not rounding until the end, so we're not doing any early rounding. So the total distance would be 16 over 19.6 plus the same again, so that's D1, that's D2, and then add on the 33 metres, and that gives us 34.6 metres. So that's a good example of vertical motion. These are the sort of things that come up in the exam. Wee bit of practice with your tutorial questions, ask us for help, and you'll be sorted with that.